Hello guys, this is Miss Amra. I'm back with my next lesson. So today we have 9-4. 9-4 is about arithmetic series. Alright, and please try not to fast forward this video because there will be a story for you guys just to kind of like give you kind of interesting kind of like idea about the whole equation, this whole lesson. So please stay tuned. Do not fast forward this video, please. All right. So we have arithmetic series. Okay, now before we did arithmetic sequence and now we have series. Okay, what's the difference? Let's just look that up first. So what I'm gonna do first, I'm still gonna show you arithmetic sequence first. So let's say I have 5, I have 10, I have 15, I have 20, 25. This is a sequence. But you know what? Let me tell you one thing. I can make this, I can change this into a series. How? So let me show you. It's going to be pretty quick. Trust me. All right. So let's change this series into, change this sequence into a series. What is that? So I'm just going to do something really quick and automatically it's just going to become series. This is gone, 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 gone. And the series is, gosh, I need to pick a different color. And now this becomes a series. All right. I hope you understand the difference. When I say a sequence, it means those numbers are just kind of like a list of number. You just have commas in there. It just lists some random integers. All right. When I say series, it's basically adding up all the numbers of a sequence. So adding up all numbers, it's basically a series of numbers, or a series of integers or series of numbers. That's what arithmetic series. If I say arithmetic means numbers are actually adding up by a common difference. Okay, so we have two different types of series. We have finite series and we have infinite series. Pretty much clear from the name. If I say finite means it does have an ending point. It's like it stops at certain term. So that's finite series. When I say infinite means it's just going to be keep going forever. It never stops and there's no last term of that series. So something like 2 plus 5 plus 8 plus 11 and 14. Done. That's a finite series. But when I say 2 plus 5 plus 8 plus 11 and ... So that's infinite series. Why? Because we don't know where it's going to stop. We don't know the last term. But let's say if I give you another example on finite. 14, and if I say n is equal to 10. This is another example on finite series. Why? Because at the same time, I have number of terms. So I know it's going to stop at 10th term of this series. So that's also an example of finite series. Okay, now how do we find the sum of a series? How do we do that? I can give you the equation right away, but trust me, there has to be you really have to understand the logic. So this is where story comes in. So this story is about great mathematician, and his name is Gauss. I don't know if you ever heard of his name before or not. Trust me, he was incredible good at math, exceptionally good at math. So when he was 9 years old, I don't remember what year he was born in, I don't remember that, but German mathematician. So what happened when he was 9 years old? So, because his teacher knew that he is really good at math, whatever she used to assign him, so he used to do everything pretty quick. So one time, just to keep him busy, teacher said, okay, hey guys, so this is what I have. I have a series like this. Like this. And she said, do one thing. Just take all these numbers starting from 1 all the way to 100. Add all these numbers and find me the sum. All right, quick. And she might have thinking oh, he might gonna take another 20-30 minutes. So just to keep him busy, let him just do that. But you know what? Gauss did this problem in 5 minutes. Trust me, even if I assign you this problem and if I ask you to literally add every single number from 1 all the way to 100, literally adding every single number and finding the sum, trust me, because you know back then there was no calculator. It wouldn't be that easy. It's not that simple. But he figured that out. He figured out a pattern. So do you want to know the pattern? Trust me, if you can actually look at that pattern, trust me, you're going to be so amazed at this whole problem. Okay, let's try understanding the pattern. What is that? Okay, so think about this. You know what he did? That's what I'm going to tell you. So he looked at this problem and he noticed a pattern. He thought, okay, look at this number. If I take this number and if I add it to this number, this makes 101, okay? Now, if I take this number and add it to this number, this is another 101. Okay, let's try with this same thing with another numbers. I take 3 and add it to 98. That makes another 101. So it means there is a pattern. What is the pattern? Because if you notice, from one side, these numbers are going up by 1, and from the other side, these numbers are going down by 1. So it means there is a pattern. So I know there would be 101 if I add 2 numbers at a time. All right? But how many times you'll see 101? Total, if you look at it, I have 1 through 100, so it means total I have 100 terms to add, and the sum I'm getting is, oh my bad, it's not 101. The sum is, so I have, the sum is 101, the total number of terms I see 100. But am I using all 100 terms to get 101? No, I'm using 2 numbers. And when you add 2 numbers, it makes 101. So it means 100, instead of 100 terms, you're using 50 terms. Why? Because you got to pair up 2 numbers to get 101. So if I take 100, divide by 2, and multiply by 101, so my answer would be 5,050. Here you go. And that's what he figured it out. And trust me, that's the coolest. That's the trick about this sum equation. So now let's try understanding the whole equation. So what he did, so in order to find the sum, what he did, he took the first term, which is A1. Remember those symbols? Added to last term. So I'm just going to say AN for the last term because that N could be any term, right? It's mainly the last term of a sequence or series. If I add first to last term, this is how we're going to find this number. How many times you would get that number? Basically, you pair up 2 numbers. So it means if you take a number of terms and if you divide by 2, so that many times you get this number here, and that's what the sum equation is. There you go. Now what I'm going to do, I'm going to show you an easy example so that you can actually understand the process and you can check the answer right away. So I'm just going to use easy one. Just look at this. Let's say I have 5, 10, 15, and 20. Again, the reason I picked this problem so that you can actually understand the whole process, and it trust me, it actually makes sense. Okay, so I know you can add them all, and you know the answer would be 50 for sure, right? 5, 50, 30, and yeah, 50. Okay, but let's just use this equation to actually check if it actually works or not. Okay, number of terms, what I see, I have 4 terms. 4 over 2. If I add my first term, which is 5, added to last term, which is 20. So 4 divided by 2 is 2. So 20 added to 5, 25. And if I multiply, it makes 50, which is, here you go, so confirmed. So that's what the idea is. So basically, in order to find sum of any sequence, any series, any arithmetic series, what you needed to know is you have to have 3 different things. You have to have number of terms, you have to have first term, you have to have last term. So as long as you have those 3 variables of a series, pretty much plug those in and find the sum. Let me just label that information for you guys. So this is how we write the symbol for sum. So I would say sum of n terms, n over 2 a1 added to an. So let me label everything for you guys. So a1 is the first term. an is the last term. N is number of terms. And this is just a symbol. So basically I would say sum of n terms. Sum of n terms. There you go. So that's how we do it. So pretty much, yeah, this is all for today. If you have any question, you can just send me a comment and I'll answer that. Thank you guys. Thank you for watching. Bye-bye.